Okay, well, I know some of you are going to shout with joy when you find out that we are done with trig and heading back to advanced algebra. So the last thing we're going to do in algebra with this class is talk about systems of equations and matrices, and that'll be one unit combined. So tonight we're going to talk about solving systems of linear equations. There is an E in there. Okay, so there are three ways to solve a system. The first way, and the least preferred way, is to graph it. So I'm going to put a little sad face, because we don't want to do that at all. Number two, we can do substitution. And number three, we could do elimination. So I'm going to go ahead and just review for you elimination and substitution today. And then if we have some time, we're going to pick up a couple of word problems. I can't seem to find my pens. That's why I'm making such a racket. Alrighty, here we go. So example 1, let's start off with substitution. So solve using substitution. Now, substitution was ideal when you automatically had a variable all by itself. Alright, so I have 3x plus 2y equals 4. 2x plus y is equal to 1. And I want you to find the value of x and y. Okay, so if we do this by substitution, step 1, isolate one variable. Okay? So you look at your equations and you see which would be the easiest variable to isolate. And I'm hoping that you see that y is easy to get by himself. So I'm going to take 2x plus y is equal to 1. So y is equal to negative 2x plus 1. Alright, so I've done step 1, which was to isolate. Step 2, make a substitution. So, since we solved the second equation for y, we're going to go back to this first equation, and we're going to make a substitution. So now we know that y, instead of calling him y, I can take out that, and I can call him negative 2x plus 1. Now we have one variable and one equation, so we're able to go ahead and solve it. So the first thing I'm going to do is distribute. So I get 3x minus 4x plus 2 equals 4. And now you're just again solving a linear, so I get negative x plus 2 is equal to 4. So I'm going to subtract the 2 from both sides. Negative x is equal to 2, so x is negative 2. Alright. And then step 3, find the other variable. So go back here to step 1 where you said y was equal to negative 2x plus 1. Now that we know x, I can find y. So I'm going to take out x and I'm going to put a negative 2 in its place. So I get that y is 5. Now, this is an ordered pair, so when you give me your final answer, it should be in an ordered pair. Negative 2, 5 is my final answer. Okay, that was called the substitution method. Alright, let's go ahead and show you how to do, well, let's go ahead and practice. Let's do a second one. If I have 5x plus 2y equals 0, and x minus 3y equals 0. Now, you don't have to label your steps. If it helps you, you can. Alright, so step 1, isolate. So I look and I decide who's going to be the easier variable to isolate. And in this case, I see that, you know what, I think I'm going to go ahead and isolate x. You want to try to isolate the one that has no coefficients. So x is equal to 3y. So x has been isolated. Alright, step 2. I want you to go back to the original equations, and I want you to go ahead and plug in what x now is. Alright, so step 2 is to make your substitution. So I know that it's 5x plus 2y equals 0, but this time I now know x. So I'm going to take out x, and I'm going to plug in 3y. And now I'm just going to go ahead and pause for a moment and let you try to solve for y. Alright. So I have my answer. If you're not ready yet, hit pause. I get that y is 0. So last step, step 3, find the missing variable. So find other variable. So I'm going to go back to this equation that x is equal to 3y, and I know y is 0, therefore x is 0. So this one's easy. The origin is my missing. Right? So that was called solving by substitution. Alright, next thing we're going to do is review how to solve by elimination. So example 2, solve by elimination. And most people have a preference which one they like better. So in just a few minutes I'm going to say, you know what, you can use any method you want. That's where I think we're going to pick up tomorrow in class. Alright, so if I solve by elimination, I need to look at these, and either I have to eliminate x or I have to eliminate y. So if I wanted to eliminate the x's, let's see, I need to get a common multiple, so I would say, you know what, or a common factor. I'd be like, hey, if I could turn this guy into a -4, they'd cross out. Or I could change these guys to a 15, one positive, one negative. But if I change him to a 15, I've got to multiply this guy, and to change him, I'd have to multiply that. Whereas if I just multiply by a -2, I can eliminate my x's and only manipulate 1. Alright, so step 1 is to multiply one or both equations. Okay, so I get 4x plus 5y equals 3, and here I get -4x plus 6y equals a -14. Now I'm ready to go ahead and combine these. Alright, so these cancel, and I have 11y is equal to -11. Now I divide by 11, and I get y is equal to -1. Okay, step 2, plug back in, find your other variable. Find the other variable. So I go back. Now, on this one, you may choose either one. What I want you to do, though, is go back and choose an original equation, because this one we've manipulated. Okay, so pick either one. I'll just pick the top one. So 4x plus 5y equals 3. And we know that y is -1. So 4x plus 5 times -1. And now I just solve this equation for x. So I get 4x minus 5 equals 3. 4x is equal to 8. So x is 2. So my final answer would be 2, -1. Alright, that's called solving by elimination. Alright, let's do one more, solving by elimination. So 3x minus 4y equals 11. 2x plus 3y equals a negative 4. Now when you look at this one, no matter which variable I choose to eliminate, I'm going to have to multiply both equations by something. So I can either change this to a 6 or change that to a 12. I'm going to go ahead and eliminate y's this time because I already have one negative and one positive. So I'm going to multiply that top equation by 3 and my second equation by 4. Okay, so this is my step 1. And I get 9x minus 12y equals 33. And I have 8x plus 12y equals a negative 16. Make sure that everybody gets that 4 and everybody gets the 3. Alright, now we're ready to go ahead and solve. And again, I'm going to go ahead and pause my screen. You see if you can figure out what x is, and then we'll join back together in just a moment. Or y is. Okay, so I've got my answer. I get that x is equal to 1. Now that I know x, I can go back to either of those equations and find the other variable. Alright, it doesn't matter which one I pick. I'm going to go ahead and pick this bottom one this time. It doesn't have any negatives except for the 4, so that way I don't potentially miss a negative. And I know that x is 1, so I get 2 plus 3y equals a negative 4, and now you just solve for y. So 3y is equal to negative 6, y is negative 2. Okay, and my final answer I'm going to go ahead and give as an ordered pair, 1, negative 2. Okay? Alright, last thing I'm going to do with you, and then if we have time we'll do word problems. We're kind of waiting to see how it goes. Example 3. Solve by the method of your choice. Identify systems with no solution and systems with an infinite many solutions. So it's possible when you solve a linear equation for you to have only one solution. That's what we've done on the first 4. However, it's possible that you get a solution or a system that has no solution, like parallel lines, or an infinite number. They're really the same line. Alright, so let's look at what we've got. We're going to pick our method. So at this point, you may choose either method that you like. So if you are a substitution person, solve it by substitution. Your elimination, solve by elimination. But quite honestly, you should look at them and figure out what is the best method. So when I look at this one, I see isolating any of my variables is going to be a little bit of work. So I'm going to say, you know what, I bet I can do this one by elimination. Because if I multiply this equation by 2, I can eliminate my x's. Alright, so I'm going to go ahead and multiply the top guy, and I actually, by 2. So I get 10x minus 4y equals 8, and negative 10x plus 4y equals 7. Well, isn't this interesting? These go away, these go away, and I have no variables. I have a statement that says 0 is equal to 15. Is that true or false? That is a false statement. Therefore, there is no solution. If it's a true statement, if down here I had 15 equals 15, then I know that I would have an infinite number. That's what happens when all your variables cancel. Alright? So what if I had x is equal to 4y minus 8, and 5x minus 20y is equal to negative 40? So the first thing I look at is, what would be the best method? Well, look, x is already isolated, so I think substitution would be my best method. So in substitution, I'm going to go ahead and start with that second equation that I didn't use. Look, x is already isolated, so I can take x out and just shove in 4y minus 8. And now I'm going to solve this equation. So 20y minus 40 minus 20y equals a negative 40. Oh, look what happens. 20y minus 20y, my y's disappear, so now I have no variable, which means I've either got no solution or an infinite number. When I look at this one, I'm like, hey, this is true. Therefore, I have an infinite number of solutions. Alright? So, I think we're going to go ahead and try to get in at least one word problem. You guys don't need to copy the word problem down. I'll give you these worksheets tomorrow in class. So, again, don't worry about writing down the problem. We're going to start off with mixture problems. So we have mixture, we have uniform motion, and then we have profit and loss. A chemist needs to mix an 18% acid solution with a 45% acid solution to obtain 12 liters of a 36% acid solution. How many liters of the acid solution should he use? Now, mixture problems are great for making a box. So in your notes, you can just go ahead and draw this box. Okay, again, don't worry about writing down the problems. I forgot to give this to you guys in class. Now, at the top of the box, you look at your amount, the percent, and the total. So this is how all your mixtures get put together. It's amount, dollars, or this could be percent, so it depends on what you're doing, and then the total. Now, we've got 18% mixture. We have a 45% mixture. And we want to end up with a 36% mixture. Okay? So, let's go ahead and fill in this percent column. So 18% I can write as 0.18. 45% I can write as 0.45. And 36% 0.36. So my question is, how much of the 18% do I need? I have no clue. That's the question. How many liters of each? I don't know. Call it X. How much of the 45%? I don't know. But I can't call it X because X is the amount of the 18%. Chances are I'm going to add a different amount of each. So let's call him Y. Do you know how much of the 36% you want? Yes, it tells me right here, I want 12 liters. So I know that is 12. Now to get your total, you're going to take the amount times the percent. So my total is 0.18x, 0.45y, and now I'd multiply 12 times 0.36, and I get 4.32. Okay? The ends become your equation. So I have one equation, x plus y equals 12. and this is my other equation. Now when I write it down, I'm going to go ahead and get rid of these decimal places, because those decimal places, in my opinion, are going to really mess me up. So do you agree that I can write that as 18x, I moved the decimal twice, plus 45y, I moved the decimal twice, equals 432. I moved the decimal twice. Now this is a system that we've been solving, and this is where we'll pick up tomorrow. Alright? You guys have a great evening. Don't forget, tomorrow we're also going to finish our test if you hadn't done so today.